What's poppin', y'all? It's me. Oh, wait. I bet y'all wondering who I am. We gonna get at that.
Yeah,
Anyways, we finna learn about some stoichiometry. But before we do that, let me show you who I really am. It's Shawnee's baby! Yeah, bust down, Stoichiana, bust down. I wanna see you learn now. Bust down, Stoichiana, bust down, Stoichiana. I wanna see you bust down. Pick it up, now write down. Speed, bust it, bust down, bust down on the gang. Stoichiometry, yeah, I know they're really fond of me. The reactions and the products I use go stupid, but that don't really bother me. I wanna see the mass now. Measure the amount of matter. We gon' learn this, no cap. We took it back, so I had to double back on the chemist. Thinking high off the moles. Tried to learn it 2 times, wasn't enough. Then the chemist relapsed, ain't no feeling, Stoichiana, we gon' take this. Hey y'all, I think we done. Psych, bitch. When dealing with moles, there are 4 different things you need to know. First of all, you need to know about molarity. To find the volume solution, the formula for molarity is moles over liters. Next, you need to know about Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd power, which also equals 1 mole. Furthermore, you need to know about the volume gas, which may show up in liters. 1 mole equals 22.4 liters. Lastly, you want to know about the molar mass. The molar mass also equals 1 mole. Now let's move on to mole conversions. How many molecules are present in a sample of carbon dioxide, CO2, with a mass of 168.2 grams? In order to set up the problem, you want to start with the given. 168.2 grams of carbon dioxide is the given. So next we have to cancel that. So we would put the molar mass of CO2 on the bottom. How do you find the molar mass, you may ask? The mass of carbon is 12.01 grams. The mass of oxygen is 16 grams. But in CO2, we have 2 oxygens, so we have to multiply 16 times 2, and you have to add the 2 together. So our total is 44.01 grams, and that is our molar mass. So now we have our molar mass. So that cancels out. So now we have to put 1 mole on the top and 1 mole on the bottom in order to cancel the 2 out. And now we have to use Avogadro's number. Avogadro's number? Remember when I told you 6.02 times 10 to the 23rd? We need it now. Now let's solve this problem. We start off with 168.2 grams of CO2, and we place the molar mass on the bottom, which is 44.01 grams of CO2. We put the mole on top, and then we move on to our next bracket. We put 1 mole on the bottom, and then we use Avogadro's number to put it on top, which is 6.02 times 10 to the 23rd molecules. Now what's our final answer? You can't do that in your head, silly. Grab a calculator. Our final answer is 2.30 times 10 to the 23rd molecules of carbon dioxide. Congratulations, you made it to the end. We almost finished, y'all, I swear. What volume of 10 m sodium hydroxide must be used to prepare 500 milliliters of 2.50 m solution? The formula we are going to use for this problem is M1V1 equals M2V2. In the problem, they already give us M1, V1, M2. M1 is 2.50 M, V1 is 500 milliliters, M2 is 10 M. Since they have given us the 3 that we need, all we have to find is V2. So we're going to transfer M2 to the other side, which is going to be divided by M1 and V1. Now let's hurry up and plug these holes in, cause
You want to take a nap?
I'm taking a nap here.
Once you plug it in, you're going to have 2.50 molarity times 500 milliliters over 10 molarity. Need your calculator. So once you plug that in the calculator, your answer is going to be 125 milliliters. And now we got some A's. And now it's time for me to go to sleep, cause baby.
Get out my room!